Hi, I'm Mr. Kangas, and today we're going to take a look at Chapter 11, Section 2. And in this video, we're going to talk about how to find the area of any figure, any 2D figure that has more than 4 sides. Something we haven't talked about yet, but in this section, one of the expectations is that you'll be able to find the volume of hexagonal prisms, pentagonal prisms, octagonal prisms, prisms whose bases have more than 4 sides. So that's why you need to know how to find the area of these hexagons and pentagons, because in order to find the volume of a prism, remember, it's area of the base times height of the prism. And if the base is a hexagon, you need to know how to find the area of a hexagon. If the base is a pentagon, you need to know how to find the area of a pentagon. If the base is a triangle, you need to know how to find the area of a triangle by doing 1/2 times base times height of the triangle times height of the prism. So you need to be able to plug in that area formula and then multiply it by height of the prism. Now, any figure that has more than 4 sides, the process for finding area of that figure is the same, no matter if it has 5 sides or 6 sides or 7 sides or 8 sides. The only variable is how many sides it has. The number, basically every figure with more than 4 sides. If we take a look, I'm going to draw a hexagon. Okay. Every figure with more than 4 sides can be split into a certain amount of triangles. It can be split into a bunch of triangles. The number of triangles you can split it into is equal to the number of sides the figure has. That's important. Write that down. I'm going to say it one more time. Take notes on this, please. The number of triangles a figure can be split into is equal to the number of sides that it has. So a hexagon has 6 sides. So by connecting all of the diagonals, or all the corners, I can split my hexagon, which has 6 sides, into 6 triangles. Now, the hexagons and pentagons and octagons, the shapes of more than 4 sides that you're going to be working with, are going to be regular hexagons, regular pentagons, etc. And the reason why I'm emphasizing that is regular means that all 6 sides of this pentagon are the same length. Because that is true, all 6 of these triangles have the same area. So all you need to do to find the area of this hexagon is to find the area of one of these triangles and then multiply it by 6. Now, if this was an octagon, which has 8 sides, I would have 8 triangles. So instead of finding the area of one triangle and multiplying it by 6, with an octagon, since it has 8 triangles, I would multiply the area of one triangle by 8. So that's really the only change you're going to notice in these shapes. The bigger they get, the more sides they get. The only difference is, what do you multiply the area of the triangle by? So the area of any 4-sided figure is 1/2 times base times height of the triangle inside, of one of the triangles inside, times the number of triangles inside the figure. Okay? So with the hexagon, there are 6 triangles inside it. So I would do 1/2 times the base times the height to get the area of one triangle, and I would multiply that number by the number of triangles, which in this case is 6. If there were 7 triangles inside, I would multiply it by 7. If there were 8, I would multiply it by 8. 9, I would multiply it by 9. Now, the one thing you need, or the 2 things you need to have in order to find the area of, this figure is, you need to have the base of the triangle. So in other words, you need to know how long each of the sides of the hexagon are. So if one side is 4, okay, that's one piece of information. I can plug that in. The base of my triangle is 4. I also need the height of my triangle, which is the distance from the center of the figure to the perpendicular distance from the center to the middle of one side. Okay, so here's one of the sides of my hexagon, here's the exact middle. So I would also need the height of the triangle, which would be represented by this line right here that I drew from the center or the top of the triangle, that perpendicular down through the middle of its base, or in other words, the side of my hexagon. So if the height was 6, I would plug my 6 in here. Now I can find the area of one triangle, and I would multiply all of that by 6 because I have 6 triangles inside my hexagon. So 1/2 times 4 is 2, times 6 is 12. So the area of this triangle is 12 inches squared. Then I would multiply all that by 6 because there are 6 triangles that have an area of 12 inches squared, and you would total out with an area of 72 inches squared. Alright, so that is how you would find the area of any figure that has more than 4 sides. So hopefully that helps. Tune in for the next video.